Hey GED students, it's GED question of the daytime, and I'm asking weird questions again. Weird questions related to the concept of divisibility. Super important concept both for the first 5 problems of your GED and because it's used in so many other GED topics from fractions to algebra. So let's take a look. If a number is a multiple of 6, meaning it's on the 6 times tables. That's what it means to be a multiple of 6. It must be divisible by which of the following? Okay, so let's think about this. If a number is on the 6 times tables, let me bust out my pen here. It's a multiple of 6, like 6, 12, 18, 24, and so on. It must be divisible by which of the following? First of all, would a number on the 6 times tables be divisible by 2? Let's think about this. We know that all the numbers on the 2 times tables, hopefully you know if you've been practicing your divisibility, are even. So let's think about the numbers on the 6 times tables. Are they all even? 6, 12, 18, 24, 30. Yes, absolutely. How about the 3 times tables? You know, the 3 times tables, 3, 6, 9, 12, 15, 18, so on and so forth. What's the pattern to the 3 times tables? Well, I hope you know, and if you don't know, you should go check out the video now because it's one of the best tricks I have. That you can do a sum of digits trick to check for the 3 times tables. Basically, if the individual digits of a number adds to something on the 3 times tables, then the number itself is also divisible by 3. So 6, of course, is divisible by 3, but starting with 12, 1 plus 2 is 3. 12 is on the 3 times tables. 1 plus 8 is 9. 9 is on the 3 times tables, so is 18. 2 plus 4 is 6. 6 is on the 3 times table, so is 24. So I'm examining these 24 times tables. They're all passing the test for divisibility by 3. Now let's think about 5. Are these numbers on the 6 times tables all divisible by 5? Well, what a silly question. We've been listing out the 6 times tables. We haven't even reached one yet that would be on the 5 times tables because we haven't even reached a number that ends in 5 or 0. Everything on the 5 times tables ends in 0 or 5, so this can't possibly be true. Just because it's a multiple of 6 doesn't mean it's divisible by 5. Same thing with 7. I'm looking at these multiples of 6. None of them are on the 7 times tables. And same thing with 11. I'm looking at these multiples of 6. None of them are on the 11 times tables. Now I have to say, I didn't need to do all of this work in order to figure this out. I knew right from the start that anything on the 6 times tables is divisible by 2 and 3. Why? Because I know what 6 is made of. Let me erase that. That's not what I meant to write. I know what 6 is made of, not 2. 6 is the same as multiplying together 2 and 3. He's composed of the prime factors 2 and 3. Well, guess what? What a number is composed of will determine what its times tables look like. If 6 is composed of 2 and 3, the 6 times tables will be the intersection of the 2 and 3 times tables. Let me show you what I mean. 2, 4, 6, 8, 10, 12, 14, 16. I'm listing out my 2 times tables. I could do the same thing and list out my 3 times tables. 3, 6, 9, 12, 15, 18, and I won't go too far. 21, 24. And now let's look at the 6 times tables. The 6 times tables, I said, were the intersection of the 2 and 3 times tables, the numbers that they share in common. Well, what's the first number that 2 and 3 have in common? Of course, it's 6, because 6 is made of 2 times 3. But look at the next number they share, 12. And the next one, 18. And the next one, 24. What do you think the next number 2 and 3 will share? It's going to be the next number in the 6 times tables, 30. And then 36 and 42 and 48, because numbers are built of their factors. It is so important to understand divisibility. It's going to help you in so many ways. But anyway, so if a number is divisible, is a multiple of 6, it must be divisible by which of the following? A and B, 2 and 3. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my very best to answer it.